Welcome everyone to our speaker series. Thank you so much for joining. Oh, that's quite a beautiful PowerPoint you guys have created. Thanks so much again for joining. This is a regular series we have 1 or 2 times a month typically on kind of innovative housing topics, anywhere from kind of the overlap between the housing, climate, and forest fire crisis to more kind of sustainable materials and design solutions for housing, to a variety of topics, maybe something that our local jurisdictions are working on, maybe something about short-term rentals. It just kind of varies, and we're always open to suggestions from the public. So please do send them our way if you would ever like to. I'm just going to very quickly go through a little bit about Mountain Housing Council and Tahoe Truckee Community Foundation for anyone who's new to us. As many to all of you know, we are here to kind of serve our community and to basically come up with programs that our community most needs. Whether that's scholarships, housing solutions, and coming together as a group to kind of work on those solutions. The Forest Futures programs, which provides grants for local work on our forests to help reduce wildfires, to a variety of different types of programs that we offer our community. This speaker series was started just because, not only our board of directors, who are shown here, as well as our staff, but our community members really needed some form of educational kind of topics to be provided on housing and kind of the overlap between housing and some of our other key issues that face our community that we have programs on at Tahoe Truckee Community Foundation. So really, it's an educational component. It's an outreach component. We are limited since COVID and to doing them virtually. We're hoping soon maybe we can do more in person and really draw in more people who may not hear about these virtually. Maybe people kind of outside of our typical attendees. But really, we're here to help our community, and we're helped to providing tools, and that includes a connection to folks like Megan and Lisa, who are here today to talk about some of these innovative design solutions that they've got put into practice. So that's really kind of what our whole speaker series is about. Typically, we have 30 minutes for our speakers to kind of go through their content, and we ask folks to either hold on to any questions they want to ask in person or just type their questions into the chat box during that time, and we can ask those questions for them. And then we provide a 15 to 20-minute Q&A after the speakers are done. So with that, I'm going to go ahead and get us started. And go ahead, Lisa and Megan will be sharing their screen and kind of driving their own slides today. So go ahead, folks, and let's dive right in.
Okay, I think I will just get going with the beginning part of this. I've actually, for 20 years, had a place up in, this is Lisa Gelfand, and I've had a place up in Serene Lakes. So that's my view of one of those lakes. And for the whole of my career in architecture, it sort of started with this idea that the primitive hut and little houses are just the source of everything that every architect ever did. And certainly we feel like we're in paradise up there. So where it all comes together is how are we going to keep doing stuff so that we continue to feel like we're in paradise and that we haven't just destroyed the whole place. And so one of the ideas is to think about just how do we build with wood? Do we build with wood the way that we always did? Or is this something that we could change that would actually start to benefit both the building process, but also the forests? So I invited Megan to talk about it because she's actually been doing it. So Megan, do you want to talk a little bit about just what your connection to this is?
Real quick. So yeah, Megan Stringer. I'm a structural engineer. I work down in the Bay Area in San Francisco at a company called Holmes, and we have kind of offices up and down the West Coast. I started on my first mass timber project back in 2015. Worked on a two-story public library building out in the East Bay in Brentwood, California. Then I started working on a pretty large project. It was actually North America's largest mass timber building. back in 2015, and that took about 5 years to complete. So since then, been working on a bunch more, and I think our company overall has been doing, I think we're on our 50th, over 50 mass timber projects, either completed in design or in construction. So yeah, happy to kind of share some of the things we've learned and kind of show you all some specific applications that would be relevant to your community.
Yeah, and I wanted to just start with this image because this is actually some housing, some affordable housing in Sacramento. It's a Holmes project, and the mass timber, which is the floor assembly, came from British Columbia. And so you got to ask yourself, what is it about just being down the road that means that they have to go get their wood all the way from British Columbia? And, when I asked Megan about it, she said, well, that's local. It's West Coast. Well, anyway, we can all talk about what is local. So, there's a lot of different kinds of mass timber. And CLT is maybe the one that people have heard about the most. It's basically dimensional timber laid up parallel and then perpendicular. So you've got the crossing at 90 degrees. That's what's up here in upper left. You could do it with nails. You could do it with glue. You could do tongue and groove. My cabin in Serene Lakes has got a tongue and groove roof deck. So this has been around. And DLT would just be laminated with a dowel. And mass plywood is just, if you just kept laying up your plywood, again, perpendicular and different plies, you get another way of doing it. One of the advantages of having mass timber is in fire. We've all had fireplaces. It's really hard. You can't just hold a match to a log and get it going. And so that's one of the really important things about this kind of wood construction as opposed to light frame, is that it really has fire resistance. So it takes really big facilities to make it. I was looking for just the 100,000 square foot plant up in British Columbia. These presses are enormous, but that's what takes the product that comes out of here could be 30 feet long or 40 feet long. All the different plants have different capabilities, but they all need kiln dried lumber. And one of the advantages that we wanted to bring up to everybody is that you can, as opposed to dimensional lumber, where if I need a big rafter and I need it to be a 4x12, it needs to come out of a pretty big tree. The CLT or mass timber products are made out of small trees. And, lumber companies say, well, they don't want to bother with small trees. And that's why they're pretty happy to be up there in British Columbia. But I found this study that was basically looking at how do you get an efficient process out of small diameter timber. So there's a ton of experts involved here. And, as I was telling Christina, as an architect, I'm not an expert in any of these, but, bring them all together and say, well, foresters, this is how we could prevent, the image on the left is how to use thinning to help prevent wildfires and crown fires. To look at the image on the right for everybody who's thinking about why Sierra Pacific says they can't afford to do this, and say, well, actually, no. This has been studied in the Southeast, and it's been studied in Europe for decades. And there really are ways to start answering some of those questions that somebody might say, well, you're not an expert, you don't understand. There are, and there's lots of attention from the Forest Service, from other people in industry as to how we could really do this in a way that promotes the health of forests, biodiversity, the safety of communities that are on the wildland-urban interface. These are all things that come together in looking at basically a new way to build things. So that's kind of the background for why this would be a great idea for us. And Megan's going to show us just how it works.
All right, I'm going to share my screen. Okay, so yeah, thanks, Lisa. Yeah, we're going to talk about some practical applications. I think first and foremost, whenever I talk about mass timber, I think one of the biggest lessons learned from all of the projects that we've done is is when it comes to the grid. And what I mean by that is that, yeah, how you're setting out your columns and your beams and your elements. I think you need to think about mass timber as a pre-manufactured element, and note that every manufacturer wants to manufacture a particular panel size that's optimal for their manufacturing plant. So whether that's typically around a 10-foot width, although that varies as well, up to 40 feet long, like Lisa mentioned, or even 60 feet, depending on the plant. So thinking about that when you're starting to set out your grids will help you come up with an optimal grid that'll work also well with a mass timber element. And so today we're going to talk about 4 different types of grids that we've successfully implemented on projects. This first up is kind of what I call optimum office. And Lisa just mentioned that the 30 by 30 grid is a very optimal grid for schools. So when you think about a 30 by 30 grid, this works really well in commercial applications and school applications. It integrates well if you have parking below, because you can work, fit 3 cars within 30 feet really well. I think overall, this type of grid has probably a larger structural depth, total structural depth, in that you need to have beams in 2 directions. So you're going to have purlins in the one direction that actually support that the panels span to, and then you're going to pick up those purlins with girders. There's definitely also options in this to substitute out any of the wood glulam members for steel or even precast concrete. So that picture there is just showing a precast concrete example and how that looks. Kind of this next grid option that we'll talk about is if you're really looking to minimize your volume of timber, and by minimizing that volume of timber, you're really going to get to the more cost-efficient solution, because when you are pricing this type of system, it really comes down to just the volume of timber that you have in your project. So this system really kind of maximizes that span of your mass timber floor. So typically you're looking at spanning your mass timber panels roughly 15 feet, and then going with up to a 30-foot wide grid in the opposite direction. Again, you could start to look at supporting or swapping out those beams with either steel or concrete. I think another also different option when we're talking about minimizing volume looks at what's called a rib deck. So it's kind of like a precast concrete double T, in that it's a pre-manufactured kind of like a wood double T that comes out. And there's a couple pictures of that showing up on the right. But again, this allows for slightly longer spans and keeps the material volume pretty efficient. This kind of other option is yeah, I guess hinting at trying to push for even slightly bigger grids. And that's again where you're implementing in like a steel or precast concrete alternate that can kind of help you push out your spans a bit. And then this last system that we've actually been seeing a lot in multifamily residential recently really looks at maximizing your floor-to-floor heights. And this system obviously integrates really well with your MEP systems, in that you don't have any beams or anything at your soffit. So you have a completely flat soffit. I think one thing to note in these point-supported systems is kind of what it's called, or post and plank. You're really going to be limited on how wide the panels can be manufactured to. So that's typically why you're governed to around a 10-foot in the one direction. Now note, if you're getting your panels from Europe, for example, a shipping container typical width is 7'3". So you got to start to think on different grids based on which type of system you're using. This system does work really well in multifamily residential, in that you typically have a lot of bearing walls or a lot of places where you can hide your columns within your walls. Now note, they also, this type of system hasn't been built very much yet. There's a lot in design currently, but I think there's really only one main example of this that have already been built, and that's the Brock Commons building up in BC. Kind of another hybrid take on a point-supported system is if you integrate a proprietary system that's called the Delta Beam system, and that's kind of what that little steel, it's kind of shaped like a little trapezoid. It looks like it was basically taken from kind of precast concrete construction, where you can span this steel Delta beam that you do have to cast a concrete topping slab on top of this to get it all to work, but it does allow you to kind of increase your spans a bit by having and still remaining with a relatively flat soffit. And so again, as I was mentioning, your supplier will really matter. So this table is just showing kind of the main North American suppliers. I think most of them are located up in British Columbia, some are in Oregon or in Washington, but that's where the majority of our mass timber is coming from, down in California. I think you just, again, want to realize that each manufacturer has different capabilities. And so you can see on this screen kind of their max panel dimensions. And whenever you're thinking mass timber, that manufacturer wants to produce the largest panel size that they can that fits in their big presses. So you got to think about that when you're, again, laying out your grids. For example, I worked on the really big commercial project that I worked on that was the largest. We ended up on a 22-foot by 22-foot grid. And a lot of the manufacturers almost didn't bid on the project because they typically had a 40-foot long press. And by manufacturing our panels, like 18 feet of their press would be empty while they were manufacturing our panels. So again, in hindsight, had we known that ahead of time, we probably would have chosen a different grid with the architect. But anyway, there are a lot of reasons why that came about, which we can get into at a different time. But again, so just really trying to stress that each manufacturer has different sweet spots for their panels, and they have different CNC capabilities as well. So just something to pay attention when you are choosing a manufacturer for your projects. I think the other most bigger lessons learned that I've come across in my mass timber projects is that it's really the most successful projects are the ones that can integrate in the MEP. And I think that can't be overstressed. Typically, in typical the design process, this MEP integration with structure and architecture happens a little bit later in design, and with mass timber projects, it really needs to happen much earlier so that you can really integrate in those systems together. And there's a lot of different ways to do that. These are just showing a couple of the options of how you could integrate that in with your floor system here. And again, there's plenty others as well. But again, all of these strategies we're seeing in play now and getting designed. And I think that also leads into a bit about this push in this industry to really, how do you pre-manufacture a lot of these really larger pieces of a building that can come shipped onto site that already have the floor panels and the MEP and all of that integrated, and then get lifted into site or lifted on site and into place so that you're really reducing the amount of field time and construction time for building. So a couple examples of seeing some of this MEP integration are kind of shown here. So looking at on the left, just that gapped CLT option where you're basically just spanning a plywood in that gap, and it does allow you to run services, small services. And then the picture on the right is showing where you're kind of layering your structure so that you can push down your girders so that you have a cavity over top that you can run small services. And so looking at how that then relates into projects, there's a lot of, we have a lot of low to mid-rise examples, and I'll just show you some here. So first up, we're going to be talking about a lot of structural systems where you have your typical, plywood or cold form steel walls that are also doing gravity, supporting your gravity loads, but also doing your lateral taking your lateral loads as well. This is a 16,000 square foot project in Portland that's going to be completed later this year, but you can see that first CLT panel getting lifted into place. Kind of again, another very similar project, a little bit bigger at 140,000 square feet, 6-story. Again, really sticking with the stick frame, conventional stick framing for all your walls, and then just swapping out those kind of TGI floors with mass timber. Again, another example shown here. This is in Santa Cruz, California. A very similar construction type. A lot of these that we've just seen have been over a concrete podium. That's very common, and you can see what that CLT soffit looks like a bit on that picture on the right. And so this like multifamily housing is really a sweet spot for mass timber, and that a lot of times the floors are replicated as you go up the height of your building. And so again, thinking about mass timber as a pre-manufactured element, and the more that they can replicate kind of that same panel dimension over and over again, the more efficient your project's going to be. So a slightly different take on a multifamily approach, and this is an affordable housing project in Santa Cruz that's in design right now. This system, we actually started this project as cold form steel bearing walls with CLT panel floors. And once we got that priced, the steel was coming in pretty high. So we actually switched this whole building, this whole system to a point supported system. So basically we just have columns and the CLT panels sitting on top of them. So we have a pretty tight grid, but again, it works pretty well with the unit layouts. This is a type 4B project, so it does need a 2-hour fire rating. And we are allowed to expose 20% of the ceiling area in this project. Note that some future code provisions that are coming is allowing in a type 4B construction a full 100% ceiling exposure in these types of projects. So something that we may try and push with the permitting jurisdiction for this project once we go in for permit, but we'll see how that works. And then some high-rise examples. So again, a little bit more of the same. Both of these projects are actually the same structural system, so that point supported or post and plank system, getting up to 12 stories here, and yeah, almost 300,000 square feet of affordable housing in San Jose. And then probably the last example of this is just another example. This project's actually up in Portland. Again, another point supported system that we're seeing for multifamily housing. And then some low-rise commercial options. This is, I think, where you probably get a little bit more of these hybrid systems. So this was for that a tech campus down in Mountain View. This was the largest project in construction and I guess that's been completed. I know that there's a lot more bigger projects in design currently, but we'll hold on to that title a little bit longer. But this project was a bit unique in that we had composite steel beams, and we also had a composite CLT and concrete floor. So that did just allow us to span a bit further, and we reached a 22-foot span on the CLT and concrete floor slab. This was for another commercial application where we utilize mass timber, again, just showing some really pretty exposed timber. This is showing a layered approach where the girders are pushed down from the purlins, and then you have your panel spanning between purlins. Another project down in San Bruno that has like a very curvy undulating roof, but does utilize glulam beams and purlins, and then CLT spanning to them. And then this is my last slide. I just thought I would leave you guys with a couple of just things to think about, and be happy to talk more in the Q&A. But in these mass timber projects, you really need to look at your project team and selecting the right team to make it a successful project. I think we've had plenty of projects start, and if they don't have the right team on board, whether that's a contractor that's knowledgeable in mass timber, or an owner or an architect that's willing to and understand just the differences that a mass timber project is over a conventional, concrete or steel project, is really just going to be key to keeping your project mass timber throughout the whole process. I think another key thing that we didn't really talk about is that fire integration and how that plays. Mass timber, the timber and the fire is a really close relationship. And so you need to have a good fire engineer on board to help you in your designs. I think procurement is another thing that we can talk more about, and just, volume of timber for your project, how you go about, getting onto the schedule of some of these manufacturers. That's really what you're doing, is you're buying a a slot in their production schedule, and you really need to hit that slot. And again, just understanding where your timber is coming from, I think is also key. I think construction tolerance is also something important to talk about in projects where you have multiple structural materials, whether that's concrete and steel integrating in with your wood. Each material has a different tolerance, and so taking that into account in your detailing is going to be helpful. Permitting, again, while CLT and all of mass timber is an allowable system per the building codes, it is still something that you may have jurisdictions that have never seen this before. So wanting to be able to understand that, walk them through that whole process and support that process will help kind of mitigate risk on your project. And then lastly, if you're trying to really push the spans of your mass timber floors, I think vibration is something that you really need to pay attention to, in that, you know, these mass timber systems are a lot lighter than the steel and concrete alternatives. So really needing to analyze floor vibrations is also going to be key. And we've been actually seeing a lot of life science projects going mass timber. And so needing to do some pretty fancy vibration analyses has been critical for those projects. So I think with that, Lisa just has a couple more slides to finish this out.
Great, thanks, Megan.
Yeah, well, I think, you know, just to bring it home to Tahoe and to Truckee, these mid-rise buildings, the multifamily housing, which is such an important piece of what needs to happen in Truckee and Tahoe Basin. And then just, I put prefab pits here. They've started in there, you know, there are some that have started for schools and you know, I look at my cabin, which I just finished remodeling, almost finished remodeling, and it was a kit, and there's a lot of kit houses around the basin. So I feel like those, you know, those are all ways that it applies directly to, you know, to Tahoe. And I think if we could tie it to the work that needs to be done in the forest, and that can help us restore the health of the forests and put those trees to good use, that makes it a very circular sort of enterprise and what we've all been looking for. So it's pretty exciting. And I think just in terms of, we do a lot of schools, my office does, and you know, I'd like to do a school, and regulatory acceptance is a huge big deal on that. You know, I see that there are two big bonds for the school districts, both in Tahoe and Truckee. And if there was, you know, any consideration of using it in those school buildings, the Department of State Architect, DSA, would have to be on board. And the state architect, the boss of the state architect, is on board. So the question of whether the staffs will be able to work it out is another one. But to see it, you know, get sort of rolled out across the various opportunities would be great. So that's all we wanted to put out there, just to start everybody thinking. So whatever questions you've got.
Great. All right, let's open things up to questions. Does anybody have a question for Lisa or Megan?
I do.
Great.
Just curious if you could both expand on, I think you mentioned at one point that some of the CLT manufacturing is happening in British Columbia, is that what you said, or Washington, and then Europe? Can you just give us an overview of where the sources are, the main sources are right now, and knowing
I have another slide. Let me find it and share, but I don't know, Lisa, if you wanted to talk in the meantime.
I'll start with just you know, I was looking at what's the closest place that we could get it, and it's Oregon. And that is really kind of distressing, right? So, so that's what brings us to, you know, what are the feasible ways of using the, you know, Tahoe Forest, or convincing somebody like Sierra Pacific that runs sawmills here that this is a product that they want to get into, that they want to expand their mills and put in some of these big presses. these are you know, I think there's a major market, and that the market needs to be thought of as beyond the mountain towns themselves and into places like Fresno and Sacramento that actually border the Sierra.
So I know that there was some talk and that the governor wanted to bring a plant online in California, and I don't know where that's gone. I have been on some projects with some pretty big players where they have talked about wanting to create a plant locally and, you know, like create all the, or fabricate all the mass timber that would be used in their projects. But again, that's just kind of been talked about. We have been seeing a lot of the European players coming and being really competitive with the current market over here in North America. A lot of them have gotten their PRG 320 certification so that they meet the requirements for US use, and even talking with some of them about wanting to open up plants or partner with people locally to do that. So I think it really just I think we're going to see a lot more of that. It's just, maybe it hasn't yet happened. But again, still looking for this slide, but I do have it. But the largest supplier has been Structurelam out of British Columbia. So they actually have a plant. They just opened a second plant. And I'm not exactly sure where that is, but their main plant is out in Penticton, BC. So again, not crazy far. Well, I don't feel like that's as far as away as maybe some of the other materials that we get, but that's pretty much where a lot of the timber is coming from. A lot from BC, and then a lot, in Washington and Oregon.
So the European plants have developed a real expertise in working with smaller diameter logs. And so again, it's like, is there a way to sort of put them together with somebody like Sierra Pacific who might not even want to cut some of those trees because they're not efficient in their current mills?
So one thing I will say and I found that slide, let me share my screen now, on the large mass timber project I worked on, we were also able to use the pine beetle killed lumber. Sorry, you're all staring at your faces. The pine beetle killed lumber as well. And so that was really cool to see. And it was almost like the architect wanted that timber because you can actually see it. It creates like a bluish gray streak in the panels, and you can visibly see it in a lot of the project. But just I guess another use for timber that is basically a waste product, but structurally it's not impacting the structural integrity of that wood. But anyway, this map probably needs to get updated. This was probably from last year, but you can kind of get an idea of where the plants are and where they are coming online soon.
Right. Christina, did you want to ask Stephen's question?
Sure, he didn't put it in the chat, but Stephen, thanks for putting in the chat that you do have a question. Go ahead.
Yeah. Okay, thanks. Can you all hear me? Am I okay?
Yes,
Am I operational? Okay, good. I actually have been to Sweden many times. I've looked at the original CLT operations that go back to 1982. We had fairly substantive discussions about the idea of bringing this back to the Tahoe. At the time, and we're talking about 2016, 2017, there just wasn't a perceived market. I think today, in 2022, is the right time. It's about $20 million to set up a facility. There are several excellent locations within the Tahoe where this could be put together. And the resistance is if I have to go to private equity, and I'm a private owner operator, so I'm somewhat sensitive to cost of capital. But if there is Sierra Pacific wouldn't do this. I mean, I've done a lot of business with SPI. They're really good guys. They'll do only what's proven and something they could sell. Frankly, they won't cut anything under 10-inch DBI, so there's nothing there for them, DBH, nothing. Everything under 10, they won't touch. So there is an enormous volume within the Tahoe and the surrounding national forests. And my opinion would be that this is the right time to build a CLT plant in the region. Now, that region is pretty broad. Transport's an issue. When you talk about, British Columbia not being that far away, it's really expensive to move that gear. We looked at CLT timber from Alberta province and from Western Ontario to build bridges, to have bridges for the Cal Fire. And they were very keen. They needed 90,000 pounds of capacity, and we could build a 52-foot long bridge module that was 1/3 the weight of what they're now using, which is railroad, rail car structures. But I think just as a reference to this group, now's the right time. And I think funds are probably generally available. I just hate government handouts. It's just 30 years in business, and I've not found any success with the government. But I think we are at the right place in the right time to raise that kind of capital privately and build a plant. My proposal would be my favorite biomass plant, which is currently closed, which is Loyalton. But there are other locations as well where that could be set up.
Well, I think Steve, thank you for that. I think that another thing that's made the time right for the market is that the building code changed, and the building code just changed. And now all of a sudden, this big regulatory hurdle that we had is gone. And that's from our point of view as designers is huge. So I think, now we really can do it. We can really put it to use. And whether, Megan showed a lot of hybrid structures, whether, if you think of it more as right now, anyway, the easiest place to go with it is substituting for steel and concrete decks. And that's today. That's something that you could make cheaper today. And, that means that right now the market really has changed.
Well, what you need to understand is the building code changes are relative, okay? It's amazing when you ultimately apply to a local council for approval, it's a nightmare. My suggestion is, since the Europeans have embraced this and it works and they're selling everything they can make and they're growing, what I had proposed and would suggest could happen in 2022, 23, 24 is partner with a Swedish, with a company that has experience in modular systems, who has no axe to grind in California politics, is happy to accommodate to global and what I would say global EU codes to California code. But my sense is we have a lot of 10-inch DVH product that is either going to burn or it has to be cut. It's called thinnings. And in my business, coming out of the biomass power industry and coming out of now, I'm making flat panels out of waste timber in Europe. I would support very actively. I currently commute to the Netherlands every couple of weeks, so I'm looking for an excuse to come back to California. And since I love Northern California, what I want everyone to know is that there is private capital available. There is an interest. Our understanding about the markets is that they are still architect driven, and that's got to change. We need architectural support, but we need commercial acceptance. Now, the cost of timber today is more than 2x, maybe 3x what it was before COVID. So the economics now are starting to look attractive for CLT and investing in a plant. A plant takes 8 or 10 acres. The fiber for it is, I wouldn't say free, because transport's the most expensive part of moving material out of the forest, but there's absolutely the right time and the right place for this group of folks, to team up to help make this happen.
Excellent. Thanks for that, Stephen. That's really interesting. All right. What next? Any remaining questions that we have out there?
I saw one that's talking about other than reducing the climate footprint, are there other aspects that make these materials more sustainable? And I guess I would just answer, so a mass timber building could have, it depends on the system, obviously, and what you'd be comparing it to, that alternate concrete or steel structure, but from an embodied carbon standpoint, you can be saving anywhere, or we can see, or in some studies that I've done, you're about a third of the impact of a concrete structure, depending on, the system. And so I think it can be really significant by just going from that concrete structure to mass timber. I think you're also seeing in these timber structures is that they're a bit lighter than that concrete or steel building, so that you're seeing savings from a foundation standpoint and as well as in your lateral systems. And so less seismic mass that you have to account for. And I think other than that, I mean, there are other ways that you can push the impact of your timber even further, whether that's through like requiring the FSC certification or SFI. And I think I lost that other thought, but anyway, there's and figuring out where your timber is being sourced from, I think, and the forest management, I think, also has been coming into play more of late. But I think those are the big benefits of the timber. And then obviously when you build with this product, you really want to leave it exposed. So again, you're reducing your cost on finishes, and as well as the embodied carbon from having to, cover up and finish that material, because the timber is your finished product. Awesome.
Great. I would imagine you and Lisa are fairly familiar with kind of what needs to be done at a regulatory level to get us using these kinds of techniques a little bit more. Can you talk about some of those challenges? Can you talk about any kind of pilot programs that have been done with local jurisdictions that have enabled some of these solutions to be put in place, just so we get an idea of kind of what needs to be done to implement something like this?
So I guess
I'm going to just say one little thing about that's not so local, that is about the DSA, that this is big public school marketplace. And, as much as their boss says this is a great thing and this is where we need to go, they are really obsessive and compulsive about connections. And so, between now and the time when they accept a mass timber shear wall, it's probably a long time. So but there's also just doing things incrementally. They're going to accept the floor ceiling system that goes on a frame much sooner. So some of it's just getting people, using the material and making change incrementally.
Interesting. Okay.
Yeah, and the use of CLT or mass timber in a gravity for your gravity framing is already allowed per code. And with the tall timber provisions that were recently adopted by California last summer, you can build up to 18, I believe it's 18 stories in mass timber. Granted, the 18 stories buildings have to be fully covered up, but you can build up to 8 stories fully exposed as long as you have that 2-hour fire rating. So I think there's a lot more options for timber and making it more viable that make it also fully code compliant. That's not to say that you won't run into a jurisdiction that's never permitted a building of that type. So I guess I have seen anywhere from needing to, sit down, have your structural engineer sit down with your permitting jurisdiction and talk to them, like go over the system with them, provide them with resources. I think Woodworks is a great company that offers a lot of free resources that can also help as well. And then I think it's just a matter of, documenting your project appropriately from an engineering standpoint, and you really shouldn't have hurdles in that sense. But I do think it's just having conversations with them, and if you are going to be asking for any like alternate means, talking with them first about that and getting them on board with your strategy and how you're going to prove that it works is all key. I think we've had multiple in-person meetings with plan checkers in the past, and all of that just to keep a project going and successful. And I will say, from a lateral system, there will be a provision to allow for CLT shear walls in the upcoming ASC 7. The shear wall type, though, that was allowed, I think it's a really skinny shear wall that's only allowed, so it's not really applicable for a lot of building types, but that is going to be in the code to be used in the coming cycle. I think for now, the rest of the CLT or mass timber shear walls that you're seeing have been getting approved through, an AMMR, sometimes needing a peer review, sometimes not. I think it just depends. I think it's up in Washington that they've adopted a provision that allows you to use CLT shear walls if you take a really big penalty on your seismic ductility factor, and if you design for it, they allow you to use it. And I think it really also depends on what's allowed per your permitting jurisdiction. I think up there, they have a lot more incentive with the wood industry and the forest industry to allow for, as much timber to get built with. So they're a lot more lenient on what's acceptable. So I think it just, again, depends and starts with a conversation. So we have done a couple buildings that have CLT shear walls, one in Sacramento, the Affordable Housing Project. We did an all CLT building up in Plumas County. They just were doing like a biomass building. It was a really small building, but we were allowed to permit that with all CLT without like a peer review or AMMR process. So again, I think it just depends on your situation and your jurisdiction.
Gotcha. The peer review process is not, completely something that, you need to really dread. It just adds another level of cost, but it may be how you can get a nervous jurisdiction to go forward is if they go out and they get a third-party reviewer or another engineer to look at it.
Yep.
Interesting. Okay. Okay, I just want to make sure other folks don't have questions. In terms of kind of associated businesses, and forgive me if you guys have already covered this and I just missed it, what kinds of associated businesses or services have to be in place in order for this to become a reality? In addition to folks like you guys who are designers, architects, bigger firms, what other businesses would we need in the region in order to kind of make this a reality? Just processing plants, things for mass timber, basically?
Yeah, the contracting community is a big deal. And contractor who is familiar or accepting or interested in learning would be great, because if a contractor can't, figure out how to price it, how to bid, how to tackle the project, how to tackle sourcing, all those kinds of things, it's not going to happen. So the contracting community is a big player here.
Right. Okay. Right. Well, fortunately, we have a pretty robust contractors association filled with people who are so very eager to develop innovative housing solutions. They're one of our great partners. So I think we have that in place, which is great. But I'm just interested in whether we would need some kind of processing plants, I guess, that might be difficult to get up and running, or maybe not.
No, it's just funny that all the little pieces, it was interesting to me that all of the lumber that goes into even before it goes into the presses, it's all kiln dried. So who's got the kilns? Where is that happening? There's a support system here that, basically from the woods to the product that involves a lot of players. But I think that's, once, it does feel like once there was a market, some people would be, you'd be able to get that kind of investment going.
There's a remarkably complex chicken and the egg in this business. We see it all the time in that you need a harvesting system for under 10-inch DBH, which there's no market for. You need a transport system, and you need a production system. I have always dealt in this world of things that don't fit. And my experience over the last 5, 6, 7 years has been that CLT won't come to the US because there's no acceptance of the technology. I think we're over that. I frankly think today we have every opportunity for that to be part of the real world. What I am still struggling with is, the cost of harvesting selected, which is really thinnings, coupled to, because the traditional loggers won't touch it. They just won't touch it. They have no interest. But when you put a price on it, they want $60, $70, $80 a ton, which puts you out of market for a waste product. When I say waste, a product that's not in market for them. It's ancillary. And when it comes to a CLT plant, we know what the cost is once we have it, once we can build it. I think the market is coming close to being commercial, and it may take a little bit of help in terms of all these billions of dollars that are now floating around. But I'm not the smart guy to figure that part out. I'm an execution guy. We can deliver if you all can help with the financing structures, or at least access to financing.
Interesting. Okay. All right. Does anybody
have a question? So I know it's at multi-rise buildings, like low, medium density, multifamily. And I know it's because it's so expensive. Like, what are the barriers to doing a single family home? What is the cost compared to a conventional house?
So I don't know the exact numbers, but we have done some single family homes in timber, mass timber. But again, it's usually for very wealthy people that want to do it because they want to, I don't know, have some funky cantilevered system, and they want to show off the timber. I think at the end of the day, because you can, like, stick frame, if you think about it, it's these thin 2x members that are spaced at a decent spacing. So just like volume of timber wise, it's very different from a very dense, thick panelized element. So it's just not required for something that's not as loaded as heavily. So where we have seen the timber in houses, it's been for like floors or roofs. And so we have been able to see it and have been designing actually up in the Tahoe area, a couple projects that are looking at timber for that. But again, it is, I guess maybe if you were already going to have to go with some type of concrete floor system for your house, like maybe a mass timber floor would be not much more expensive than that. I think it just, I guess if you're just though comparing it from just a traditional house, it's just going to be more expensive because it's a lot more volume of timber than just your conventional stick frame.
Well, and up where I am in Serene Lakes, it's 450 pounds a square foot on the roof for the snow. And so now we get into looking at things that, your basic 1/2-inch plywood's not going to do. So, so I think that there are areas, and I brought up kits because once you get one of these big plants geared up to produce product, they want to just keep producing it. And if there is enough volume, it doesn't all have to be volume that goes in one building. It could be volume that goes in a bunch of buildings. If there was an ADU project that said these are cottages available to put 50 of them available to put in 50 backyards, then that's something that you might get some benefit out of the mass production. Because a lot of the other benefits are there. The floors, the roofs, the glue lamps. I mean, you'll start seeing all the pieces of mass timber all over the place now that, we've shown you what they look like. Even just looking at my cabin built in the 70s and what was used by dimensional timber then, when we added to it, we made out of glue lamp because you just can't get that dimensional timber anymore. Or if you get it, it's certainly not dry. So so I think that there are areas where it's getting into the single family home world. It's just not, if it's a one-off, you have to expect it at this point still to be more expensive.
Thank you.
Great. Well, thank you so much, Megan and Lisa. Again, this has been really, really interesting and just very exciting that we could maybe get something like this going in our region. So thank you both so much for sharing with us. And I'm hoping you let us stay in touch with you if there are follow-up questions and maybe just need for advice at different times. So thank you again. And thank you for all the wonderful work that you're doing. It's obviously making a difference and it's really exciting and cool. Just to let everybody know that we've got some other events coming up. Christina's sharing her screen now. We have a pretty exciting event on March 16th. It's going to be more of what some call a hackathon. It's kind of a brainstorming session where we get some of the folks from Telluride's Affordable Housing Temporary Winter Community Housing Program to join us, and we basically hash out how we could get the same thing going here. We already have an employer who's basically done a van life program, Palisades, just started moving people in last week. And it's basically an on-site employee housing program that involves RVs. So it's very similar to Telluride's program, and we really want to get something like that going, as well as kind of its equivalent for the summer here. So that's what it's going to be. It's going to be really kind of step-by-step instructions, how we start, where we go, how we find land, how we apply to town council or board, and then kind of how we start moving people in and all of that. So please do join us. Again, it's free, just like today's. Our April 21st topic is going to involve the upcoming California regulations with the insurance industry, and kind of having insurance companies basically provide rewards, discounts, and all of that for folks who wildfire proof their homes and who do defensible space measures. So that's going to be really exciting. We'll talk about that and kind of how it might overlap with our housing situation. So thank you, all of you, for joining us for these wonderful events. We will keep doing them, and hopefully one day we will have them in person with snacks and things like that. So thank you so much again, and all of you, please have a wonderful evening. Thank you.